Okay, so we just talked about how to solve systems by graphing, which is great, but sometimes graphing isn't necessarily the best way to solve a system. And so we hinted a little bit at some of the disadvantages of graphing. Let's talk about the second of three methods that we're going to learn for solving systems, which is something called substitution. So substitution does not require graph paper at all. There's no graphing involved when you do substitution. But it does require a huge amount of algebra. Yeah. So if you're an algebra expert, and at this point in the semester, I'd say that's all of you, you're welcome. Substitution is going to be right up your alley. Wow, haven't even done a single problem and already out with the negativity.
I didn't get it as much as whenever I think it was one class period I missed, and I did the videos online, and I just didn't get how to do substitution.
So what you're telling me is you had a previous math teacher that really screwed up, and this is my chance to shine and right all of their wrongs.
Yes.
Well, I've got some good news for you. I have a lot of experience correcting mistakes. So here's how substitution works. It starts off similar to slope-intercept form in that one of your goals is to solve an equation for a variable. Now right off the bat, that should sound way simpler than getting something in slope-intercept form. When you get something in slope-intercept form, you have to solve both equations for y. Both equations have to be y equals. When you solve something by substitution, only one of them has to be solved for a variable, and it doesn't have to be y. I could solve for x or y on the top or the bottom. This is valuable to us because if you look at this pair of equations I've given you, one of them's already done. That one's already solved for y. Already solved for x. X equals y plus 2. Now here's where the substitution part comes in. X equals y plus 2 means something really important. This equal sign right here means instead of. I can write x instead of y plus 2, and even more important, I can write y plus 2 instead of x. Look at this top equation. What would this equation look like if instead of x, I wrote y plus 2? Let's just try that out. So 2, and instead of times x, I'm going to do times y plus 2. I'm going to keep everything else the same, but the x is going to be replaced or substituted with y plus 2. So that if x and y plus 2 are equal to one another, I should be able to replace this x with y plus 2. Right? Okay, so look at this new thing that I wrote. When you look at this, probably what you are thinking is, you made that way, way worse. You have ruined this problem because 2x plus y equals 10 didn't look great, but it looked better than this. Yeah. So why in the world would I replace the x with something way worse than x?
Because you need a second equation so you can ruin our lives.
I don't need a second equation.
You need to find a solution for y.
Exactly. It is impossible for me to tell you in this equation, 2x plus y equals 10, it is impossible for me to tell you the value of x or y. I can't solve an equation that has two variables in it. So what was my goal? Write an equation with only one variable in it. I replaced the x with something worse, yeah, but now look, I've only got y in here. Now I can solve this for y. It's going to take a little bit of algebra, but I can do it. Let's do it, gang. Distribute. 2 times y plus 2 times 2 plus y equals 10. And now we're off to the races. Let's combine the y's. I'll subtract 4 on both sides. And then divide by 3. So y equals 2. Yes. Now my goal here is to write the coordinate that both of these equations have in common. What is a coordinate that is a solution to both of those equations? And I now have half the answer. I know what the y coordinate is. The y coordinate is 2. If I were to graph those, both of them would pass through a point with a y coordinate of 2, which is great, but does not narrow it down for me because there are an infinite number of coordinates that have a y of 2. It could be 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. I have no idea. What's x? Well, we're going to do some substitution again. Now that I know what y is, take a look at this equation, the second one, the one we haven't substituted into yet. If I replaced that y with 2, I would have x equals, and I'm going to substitute the y with 2, because y equals 2. That's what we figured out down here. So 2 plus 2. Remember, you are allowed to use a calculator in this class. 2 plus 2 is 4. Hey, look. We got the answer. The x coordinate is 4. The y coordinate is 2. So the solution is 4, 2.
Another way, huh?
If you like algebra, or even if you don't like algebra, but you feel okay about doing algebra, this is going to be your preferred method, like 98% of the time. Okay? No graphing required. So if you like graphing, you're probably a little sad right now. Actually, if you like graphing, you're sad all the time. Am I right? Hey-o.
Would they be fractions?
Yeah, and the beautiful thing is when they're fractions, it's almost impossible to get the answer from graphing. But it's really easy to get the answer from substitution.
So the solution, that's telling us where they intersect.
Right, if I were to graph them, they would intersect at 4, 2. That's exactly right. All right, cool. Now, my first goal with substitution is to solve one of the equations for one of the variables. Looks like I already have that done. This one's already good to go. Y is already by itself. So look at the first equation. What would it look like if I were to replace that y with 3x? If I were to substitute 3x in place of y?
Minus 3x.
So I would have 5x minus 3x equals negative 2. That's really nice.
You're replacing a y.
We replaced the y with 3x, or substituted. So 5x minus 3x is 2x. And now I'm one step away. Divide both sides by 2. X equals negative 1. Yeah. Hey, that's great. I now know half of the answer. What's the other half?
Plug it in.
You plug in negative 1 with the x on a 3x, right?
Yep, the y equals 3x. I'm now going to substitute. X equals negative 1 is what we just learned. So,
Which is
y equals 3 times negative 1. 3 times negative 1 is negative 3 as far as I know.
So it's negative 1 negative 3.
That's exactly right.
If we, by doing substitution, could we ever get no solution or infinite solutions? Or
That is such a good question. He said, with substitution, is it possible to get no solutions or infinite solutions? Well, sure. If I give you 2 lines that don't ever cross, you'd get no solutions.
how would that look for x and y?
How would that look? That is such a good question. We should definitely do one of those.
No.
But not right now. We're going to do one in a few minutes. But before we do that, I want to show you what one looks like where your answer is a fraction, since you asked about that.
I know it's gonna show up on that little math lab.
I'm blaming you. I'm blaming you for the fraction that's about to come up here. I'm acting like I wasn't going to do it anyway so that I can blame you for the fraction. Remember, guys, I didn't want to do this, but he asked, so my hands are tied. So this one has two problems, only one of which you really would know about from looking at it. The problem you know from looking at it is that neither one of these is solved for a variable, and that's step one, is to get one of these variables by itself. The second problem you only know about because I told you, at least one of these coordinates is going to be a fraction. But we wouldn't know that just from looking at it, so let's deal with the problem that we would know about, which is that neither one of these is solved for a variable. I can solve either one of these, top or bottom, for either variable, x or y. Either one of these can be x equals or y equals. So look at those two equations and tell me, of those two, which one do you think is going to be easiest to isolate a variable?
The harder one.
Huh? Which one's that?
The top one, x plus.
Yeah, I feel like getting x by itself on the top one's going to be easiest. Why? I mean, W-H-Y question mark, not the letter Y. Why is that going to be the easiest?
The
Plus
smallest.
multiplication.
It's the smallest? Elaborate on that. I don't know what that means. Why is this going to be the easiest variable to isolate?
It's by itself.
What do you mean by it's by itself? I don't know what that means.
You wouldn't have to. It wouldn't give you a
X
fraction,
squared
right?
over
Why not?
Because it's just x by itself.
It's just x by itself. It does not have a number in front of it. In case it ever comes up, the name of that number is the coefficient. So if you're on Final Jeopardy, you may want to keep that in mind. But the simple answer is there's no number in front of the x, which means when I solve this one for x, I won't have to divide by anything. That's handy. So x plus 3y equals 6. How am I going to get x by itself? Subtract x from both sides?
Sure, why not?
Because I want x to be by itself. If I subtract x, it's going to be over here with the 6.
Well, then I guess you minus the 1.
That's good powers of deduction there. Subtract 3y on both sides. That gives me x equals negative 3y plus 6. Or 6 minus 3y, dealer's choice.
Oh, man.
Now the x is by itself. Great. I just solved the first one, so when I substitute, I'm going to substitute into the second one. So I'm going to take this equation right here, 2x plus 3y equals 10, and everywhere I have an x, I'm going to replace it with negative 3y plus 6. So instead of 2 times x, it'll be 2 times negative 3y plus 6. Everything else will be the same. Plus 3y equals 10. Now the equation that we came up with is pretty gross, but it does have one giant advantage. It's all y's. No x's involved. So distributive property. Negative 6y. And 2 times 6 is 12. Plus 3y equals it.
And then you put the y's together.
It's a good idea. Combine our like terms.
Negative 3y plus 12
Yep.
equals
So far, so good. And then
Minus 12.
minus 12. So negative 3y equals negative 2. And then divide by negative 3. And here's our fraction. Negative 2 divided by negative 3 is 2/3. I told you it was coming, but even when you see it coming, it still hurts. Still hurts a little bit. So now that I know that y is equal to negative 2/3, I am going to take this top equation here. X plus 3y equals 6. And I'm going to replace the y with 2/3. And if you're colorblind, you're really missing out on a special treat here where I decided to combine red and orange for some reason.
How do you, if it's negative, you just switch to positive?
Negative divided by negative is positive.
And like multiple.
Now this looks like it's going to be nasty, but it's not too bad. What's 3 times 2/3?
6 over 9.
Well, I got the 6 right, but not the 9.
3 times 3.
6 over 3. 3 as a fraction is 3 over 1.
Oh.
3 times 2 and 1 times 3. So this is 6 over 3, which is 2. And then
And minus 2.
I'm a big fan. I like it. So what's my answer?
4. X equals 4.
Well, 4 2/3.
4 and 2/3.
4
Where'd I lose you?
Did you multiply and divide the 2/3? 3 over 1 times 2/3?
3 over 1 times 2/3 is 2. It's 6 over 3, which reduces to 2.
Okay. That's where it gets you. So it's
Yeah, it's a
6,
missing.
3 times, so it's 3 times 2 is 6 over 3.
Right, and 6 divided by 3 is 2. You had 6/3, which reduces to 2.
2, okay.
So that's what it looks like when one of your answers is a fraction.
Get it done.
Okay? We good here? All right. By popular demand, let's see what one looks like when it has, let's say when it has not one solution. So this one will either have no solutions or infinite solutions. Spoiler alert, I'm giving away the ending here. We'll either have no solutions or infinite solutions. All right, what do you got? Step 1 is to solve one of these equations for one of these variables. I feel like the easiest thing to do is going to be to solve the bottom one for x because it's already done. So yeah, I think I'm going to go with solve the bottom one for x. Done. So look at the top one. We're going to take this top one and replace the x with 4y plus 8. So 1/4, and instead of x, 4y plus 8 minus y equals 2. Okay, let's do the distributive property. So what is 1/4 times 4y?
That's 1y.
It's 1y.
That's
1/4 times 8 is
2.
2 minus y equals 2.
Wait, 1/4 times 4y is y?
Yeah, 1/4 times 4 is
It's
1.
like dividing 4 divided by 4.
Yep, it's like multiplying by 1/4 is exactly the same as dividing by 4,
So you do 8 divided by 4.
except it makes you look more awesome.
And that would give you 2.
Right, 8 times a fourth is the same thing as 8 divided by 4, which is 2. Cool, now what?
Add the y's.
Let's combine the y's. Y minus y is, yeah, nothing. So we end up with 2 equals 2. Uh-oh. What happened? When your variables drop out like this, when you are confident your algebra has been done correctly and yet your variables are gone, This is your giveaway that the answer is either no solutions or infinite solutions. When the variables drop out, it's one or the other. It's either none or it's infinite. How do we know which one it is? Well, when the variables dropped out, did we end up with a statement that was true or false? We ended up with 2 equals 2. Is that true?
True. Yeah.
If the statement is true, that means infinite solutions. That's what it looks like when you have infinite solutions. Remember, infinite solutions is when it's the same line, one right on top of the other. So this one looks kind of goofy, but the good news is we just saved ourselves a ton of work because I only had to do one equation. I only had to substitute in the first one. I don't have to worry about substituting in the second one. That's good. All right. With that in mind, let's try this one. So we've got a problem, which is that neither one of these is solved for x or y.
You take the top one, I think it would be a lot easier, wouldn't it?
Well, it depends. Take the top one and solve for what?
Solve for x.
Why do you think that's the easiest?
Because you don't have to deal with the -8.
Yeah, I like that idea. Why could we not solve the bottom one for y then?
Well, you can, but
But
it's more work.
why is it more work?
I just look like it.
I'm not disagreeing with you, but why does it look like it?
There's a -30.
Yeah, well, the number on the end's negative, so I got 2 negatives.
Yeah.
Also, the numbers are just bigger. Like
Yeah.
they're bigger on the bottom. If I got a choice, I'm going to deal with the small numbers. So I agree with you. Let's take the top one and let's solve it for x, you said? That does seem like a really good idea. How do I do that?
So plus 3y
Mm-hmm.
to
Yep.
Plus 3.
plus 3y,
I'm a fan of that.
which is 4x
3y plus 12. Good.
plus 12. Now,
Uh-huh.
divide 4 on solve, right?
Good. You guys are so smart.
X equals
Yep.
3/4
Y.
plus y plus 16.
4,
3.
Plus 3. Good. Okay. So, step 1 done. I got one of those solved for x. Because I solved the first one for x, that means when I do my first substitution, I have to substitute it into the bottom one. Okay? So, -8, and then instead of x, 3/4 y plus 3. Plus 6y equals -30.
Wait. Why would it be? Oh, shit.
Now what?
Tell distribution first.
I think distributive property is a good idea. You guys are all right. -8 times 3/4 y.
6y.
Yeah.
-6y.
Yeah, I
Plus.
forgot the negative.
So you do is 3 times
8 over 1. It'd be 8 over 1 times 3 over 4.
It's 8 times 3 divided by 4.
Yeah.
8 times 3 is 24. 24 divided by 4 is 6.
Oh, okay, cool.
Surprised I got that.
I need to practice fractions a little bit.
I mean, this is useless.
You might need to practice fractions. I'm very busy. So now what?
Put the Y's together.
Let's put the y's together. -6y and +6y is gone.
So it's
So the y's are gone now, just like on the last one. But the difference is, on the last one, I ended up with a true statement, and on this one, I ended up with a
No solution.
not true statement. This is what no solutions looks like. No solutions, the variables drop out, and well, what you end up with is lies. Negative 24 does not equal negative 30. Who told you that? Outrageous. Any questions about that?